Okay, we have seen what or how to graph points. We've also just quickly looked at some linear functions. Now we want to continue and look at how to graph more of these linear functions. And specifically, we're going to learn how to do it with some intercepts. So when you graph a function, you can do it with intercepts. You can do it with a different form. There's lots of different ways that you can graph them. But one useful way, especially if an equation is written in a certain form, is using intercepts. So if you're wanting to find an x-intercept, and an x-intercept means the point at which it crosses this x-axis. What you do in the equation is you plug a 0 in for y, so 0 in for the other letter. And conversely, if you're looking for a y-intercept, okay, where it crosses this line, you would plug in a 0 for x. So, for example, I've got a linear function has an x-intercept of 3, 0, so it's 1, 2, 3 right there. And it has a y-intercept of 0, minus 3, so 0 left or right, and minus 3 up or down. So they ask us to graph the function. Once I know what those two intercepts are, then to graph the function is fairly straightforward. I just have to draw a line and make sure it goes through both those points. And typically I like to make sure it's extending up to the right and down to the left. And also I like to put arrows on both sides. Not sure if the book does that or not, but so that would be the line that corresponds with those two x-intercepts. So here's another line. Let's see what the intercepts are. Let's first look for the x-intercept. So here's the x-axis. So where does it cross the x-axis? Looks like it's crossing right there. So that is at 1, 2 to the left. So it's minus 2 to the left. And for the x-intercept, the y value always has to be 0. Remember, we just said that on the last slide. Okay, now the y-intercept, here's the y-axis. It crosses, looks like to be right about there. So that's 0 to the left or to the right. Again, the y-intercept is always going to have a 0 value for x, and it's 2 up. So those are the two intercepts that correspond with that particular line. Now let's go into a more interesting question. If they give me this relationship between x and y, then to graph that, which is what I'm trying to do, and again there's lots of ways to do it, but one of them is to find the intercepts. So let's try this one. To find the y-intercept, where it crosses this axis, you plug a 0 in for x. So let's do that here. So for x is equal to 0, I'd have 3 times 0 plus 4y equals 12. 3 times 0 is 0, 0 plus anything doesn't change it. So I have 4y equals 12, divide both sides by 4, I get y is equal to 3. So my y-intercept is 0, 0 to the left or right, and 3 up. So there's my point. Now there's no line yet because I don't have another point to go with. I'm hoping I get a point along here or along here for the x-intercept. So let's do that. So for this time, let's plug a 0 in for y. What do we get? So 3x plus 4 times, we're saying a 0 in for y, equals 12. Again, I get 3x is equal to 12. 4 times 0 is 0. When you add it, it doesn't change it. Divide both sides by 3, I get x is equal to a positive 4. So when I plug a 0 in for y, I get x is equal to 4. So my point is over 4 and up and down 0. So there's my point. Now I can draw my line. Oh, whoops, I got a point. Draw a line. Something like that. Okay, now with that, it might be a nice idea for us to get another point just to maybe confirm that what we're doing is right. Why don't we try another point? I could try a 1 in there maybe, or a 2. Why don't we try 2? I'm hoping that'll come out even. So let's say for x is equal to 2, what does y come out to be? So x is 2. So 3 times 2 plus 4y equals 12. 3 2s are 6, plus 4y equals 12. And again, just practicing our addition property, multiplication property, all the rest. Subtract 6 on both sides, so I get 4y is equal to 6, and divide now both sides by 4, and I get 6 over 4. If I simplify that, that's 3 over 2. And just to give it a decimal, so I'm sort of have ballpark on the graph, about 1.5. So let's check our graph and see if, when we drew our line, we get the point 2 and 1.5. Is that on our line? So I go over 2 and up 1.5. Sure enough, that line's pretty well bang, or the point is pretty well bang on my line, as it should do. Okay, let's continue on. If you wanted, maybe try this one and plug in a 0 for x, a 0 for y, and see what kind of graph you come up with. Okay, hopefully you paused and you got this. I'll just go through it quick. If I put a 0 in there, I'm going to get a positive 2 for y. If I put a 0 in there, I'm going to get a negative 3 for x. So 0, 2, there's my point. Negative 3, 0, there's my other point. Now I'll draw a line between them. So something like that. Again, arrows on both sides. Okay, hopefully you got something like that one. Okay, there's another one. You could try that one, a little bit simpler, half. And we'll be looking at another way of graphing that here in a second. But this graph is probably going to look something like this when you do it. It'll be pretty close to look like that. And after we do the next section, or the section thereafter, hopefully you should be able to just look at a graph like that and be able to identify that that's what it looks like. Okay, so we have looked at lines that can be basically sort of off kilter from the axis, something like that, or something like this. But what happens if you get a horizontal line? And what would be the x-intercepts, y-intercepts for that? When you take a look at it, for this particular line, whoops, for this line, I can't click on it anymore. There it is. If I am anywhere here except for right there, right on the axis, it doesn't cross the line. So really, for this particular one, it doesn't really matter what your x value is. The equation of this line is always going to be a y. The y value of this is always going to be negative wherever you're at. So in this particular one, it says y equals negative 3. That would be this line right there. So it doesn't matter what x is. X could be 0, 1, 2, negative 10, whatever. But the y value, because it's flat, a horizontal line, the y value will always be negative 3. And that's why the equation of a horizontal line is always y equals something. Now, similarly, if you look at a vertical line, same thing applies. If this says x is equal to 2, so x is equal to 2 over here. So it doesn't matter what y is, x is always 2. So here's another point, there's another point, and any point along that vertical line would be on that particular equation of the line. So if I draw myself a line, it'd be something like that. So it doesn't matter what y is. Y could be negative 3, negative 2, 1, 0, negative 10. Doesn't matter. X is always 2. And that's why the equation, again, looks like that. And that's something to memorize. Vertical lines, x equals something. If you have a horizontal line, it's y equals something. Okay, last sort of thing to look at in this section, and we'll look at it more in the next section, is the different forms or types of linear equations. Sometimes you'll see a linear equation that looks like this. Notice there's an x and a y in it, and then some other letters. Sometimes you'll see the equation that looks like this. Again, I have an x and a y, and I've got other letters. Turns out that it depends on what you're looking for, but sometimes this form of the equation is a good one to use, and oftentimes this one is a good one to use. So you see in the next section, we'll sort of learn how to go back and forth between those and get information from them. Last thing I wanted to just sort of push you on today, or to try, is here is 5 different formulas or equations of lines, and here are their graphs over here. Just see if you can match those up. Maybe pause and see if you can match them, and then press play and I'll take a look at them. Okay, first ones I would look at are these horizontal or the vertical lines, or this pink one here. So this one here, it looks like the y value is always 5. So it doesn't matter what x is, I can go left or right as far as I want, but the y value is always 5. So this one, y equals 5, would be that line right there, that blue one. Okay, so this pink one, it looks like here I've got an x value of -3, and it doesn't matter what y is. It could be big or small, but x is always -3. So that line there is that one. X equals -3, that's that line. Now let's look at some of the other ones. Y equals 2x minus 3. Maybe just one thing I'll try is I'll try and plug a 0 in there. So if I plug a 0 in, 2 times 0 is 0. 0 take away 3 is -3. So I should have a point on this graph of 0 minus 3. So 0 minus 3 is a point right there. Looks like this line here is the only one that has that point as part of the line. So that one is this line right there. Okay, now I just have two left. Maybe let's do the same thing with this one. Let's put a 0 in right there. 0 in for there, so my point is going to be 0, and 0 times -5 is 0. So the y value for that point is 0 as well. The only line that is crossing at 0, 0 is this green line. So that one's got to be green. Therefore, this one here must be the bluish green kind of line. Hopefully you get sort of an idea of how you can sort of eliminate equations and lines like that just by looking at their properties. All right, that's it for this section. Practice some of these in your text.